Hey everyone, I've been getting some feedback that when I do this with my camera, it's really loud and obnoxious. But I'm going to keep doing it, so sorry. Alright, today we are working on variables and equations. I think this is going to be a pretty simple lesson for you. It's going to make a lot of sense based on what we already know, so I'm excited to get into it. I have a few definitions here. I'll just box them in green if I think there's something that's worth knowing. Our first one is an equation. An equation is probably something you've heard before. Basically, all that means is it's a mathematical sentence with an equal sign. That's the big part right there. It has an equal sign. Our expressions, remember, expressions do not have equal sign. Our expressions do not have equal sign. Our equation does. So if we're looking at these right here, we have three examples of an equation because all that needs to have is an equal sign. So we got 9 plus 2 equals 11. There's an equal sign. This is an equation. X plus 7 equals 37. There's an equal sign. It's an equation. A plus negative 3 equals 2a plus 5. There's an equal sign. It's an equation. Our next one is an open sentence. Basically, an open sentence, all it's saying is it's an equation with at least one variable. So if we look back up at our examples up here, I see our variable x here, so I know that this one is an open sentence. I see our variable a and a here. I know this is an open sentence. All an open sentence is an equation with at least one variable. So if we look at our first one, 9 plus 2 equals 11. Those are all numbers. There's no variables. That is not an open sentence. Our second two both are. All right, I have 6 examples here that I want us to figure out if they are true, false, or an open sentence. To be true or false, we basically just check the math. And if the math works out, then it would be true. If it does not, it would be false. And if there's a variable, it's an open sentence. So our first one, we have 6 plus 12 equals 18. I know you all know that in your head. 6 plus 12 does equal 18. So this first one would be true. That simple. I know it seems simple. I know it seems easy. Looking at our next one, we have 3 plus 4 equals 6. I know 3 plus 4 does not equal 6. 3 plus 3 equals 6. So this one is false. Our next one, we have 6y equals negative 3 plus 5y. Right away I look at this and I see, there's a variable. There's the variable y. So I know that this is an open sentence. That's all I need to see. If I see that variable, I instantly know that's an open sentence. D, 9 minus 7 equals 3. I know 9 minus 6 equals 3, so 9 minus 7 cannot equal 3. This is false. Next one, 8 plus x equals 2. I see x there. I know that it is a variable. Our variables are our letters. I know that this has to be an open sentence. And finally, we have 4 times 5 equals 20. Do my mental math, 5, 10, 15, 20. That is true. Piece of cake. Easy lesson today, just like I told you. A lot of plugging in, a lot of stuff you already know. All right, we're going to practice a little bit of writing an equation using a sentence that they give us. So right here they tell us 9 times the opposite of 5 is 45. True, false, or open. So I'm going to start by writing this out. Right in order, I'm starting with 9 times, I'm actually going to do a dot. 9 times the opposite of 5. So we're thinking back to our opposites. I remember that an opposite is something, an opposite plus the original always adds up to 0. So I know 5 plus something equals 0. 5 plus negative 5. Our opposite of 5 is negative 5. Our opposite of 100 is negative 100. Our opposite is the negative or the positive version of the same number. So I got 9 times the opposite of 5, which is negative 5, equals 45. Okay, now we got to figure out if that is true, false, or open. I know that 9 times 5 equals 45. We have 9 times negative 5. I know a negative times a positive, those signs are different, so it is always a negative. So I know that 9 times negative 5 equals negative 45. So this would be false. This would need to be a negative in order for it to be true. This is not an open sentence because we do not have any variables. All right, our next definition here, our solution. It sounds exactly like you'd expect it would. Our solution is our answer, a value that makes an equation true. So if we're looking at an equation, the solution would be something that makes an equation work. So for example, they give us this question, 170 plus x equals 200, and ask, is 30 a solution? Well, let's find out. All we have to do to figure out if a solution is, to figure out if a number is a solution, excuse me, we plug that in for x. So I'm going to rewrite this as 170 plus 30 equals 200. Take a look at that for a second. Think about that in your head. I'm sure by now you already know. 170 plus 30 is in fact 200. So this would be a solution. 30 is a solution for this problem. It works. We checked it out, we plugged it in, and it worked out. Now sometimes you're going to see this format a little different. So I gave us 2 examples here. Right here we have a semicolon. Whenever you see this, you know that the number afterwards, this number right here, is what you're going to plug in. So 8 plus t equals 2t. All we do here is we take 1 and plug it in for t. So we're going to rewrite this as 8 plus 1 equals 2 times 1. We check it out. 8 plus 1 is 9 equals 2 times 1 is 2. 9 does not equal 2. So no, this is not a solution. Anytime you see this semicolon, you just know after that is the number you plug in. So looking at the next one, we have 9 minus m equals 3. I see 6 is after the semicolon, so I plug that in for m. 9 minus 6 equals 3. That does check out. That works. Yes, 6 is a solution. Pretty simple stuff. We're just doing a lot of plugging in. All right, we got a couple word problems, and then that's all I got for you. All right, we have on a mule ride. We're talking mules. That's like a half donkey horse, I think. On a mule ride, a rider's gear weighs 10 pounds. I see 10 pounds. I'm immediately going to write that number down. The rider plus the gear weighs 145 pounds. So I know the gear was 10 pounds. The rider plus the gear is 145 pounds. I don't know what the rider weighs. Can the rider be 160 pounds? So they want us to know is 160 a solution? And they tell us let W equal the weight of the rider. So I'm going to plug that right in here. I made my problem. They're asking us if 10 pounds for the gear plus the weight of the rider equals 145. And they want to know if the rider can weigh 160 pounds. So what are we going to do? Plug that right in for W. Rewrite this as 10 plus 160 equals 145. 10 plus 160 is 170. That does not equal 145. So the answer for this is no. 160 cannot be the rider's weight. 160 is not a solution. We plugged it in. We set up our problem to start. I did 10 plus the weight of the rider equals 145 because they told us the rider plus the gear weighs 145. And then they said, can the rider be 160? Plugged it in. It didn't work out. No, 160 cannot be the solution. One more example here. We have a tent weighs 6 pounds. I'm writing that number down. Your backpack and the tent together weigh 33 pounds. So when I hear together, I'm thinking adding my backpack plus my tent. I'm going to write T for tent Oh no, we already know the tent. We don't know the backpack. So I'm going to write B for backpack. We have the 6-pound tent plus the backpack equals 33 pounds. Does your backpack weigh 27 pounds? They're asking us, is 27 the solution here? Check it out. We plug that in. 6 plus 27 is 33. Yes. The backpack weighs 27 pounds. This is a solution. It worked out. Remember, in the equation, it's a mathematical sentence with an equal sign. Our solution is a value that makes the equation true. A lot of stuff that we already know, we're putting into work today. Still remember those PEMDAS? I think you're going to crush this lesson. Good luck.